So this week we will be focusing on finding factors and prime and composite numbers and what they are. So I'm going to kind of jump right into factors. Factors are whole numbers. So no fractions, no decimals, just a whole number like the number 2 that can be multiplied by another whole number to get the desired product or to get that desired kind of answer. So for instance, if I had the number 6, I want to find all the factors, all the numbers that can be multiplied to get me this number 6. So first thing I'm going to do is start with the number itself. I think in my head, what times 6 is going to give me 6? Oh, I know 1 times 6 is going to get me that answer, 6. And I think and do the mental math. All right, if I have the number 2, what number 2 times what gets me 6? And this is going to be kind of quick, fast math. Oh, I know. 2 times 3 are factors to get 6. 2 times 3 will always give me 6. And I think if I have the number 4, I don't think any number times 4 is going to get me 6. And I don't think number 5 times anything is going to get me 6. So 1, 2, 3, and 6 are going to be my factors to get to my desired product right here, which is 6. All right, so we're going to move on to kind of a bigger number. We're going to look at the number 18. And this week we're going to be using kind of tiles to create rectangles to help us figure out all the factors for various numbers. So I already kind of pre-started one. So as a student, I'm going to start with the number itself, which is 18. I'm going to create a rectangle of 18 squares. And I see that I only have one row. So I know 1 times 18 will get me the number 18. Now I'm going to go ahead and probably think about the number 2. I'm going to create 2 rows of rectangles. And I'm going to count down until I get the number 18. But each row needs to have the equal amount of squares. So I have 1 right here. I keep counting 2, 3, 4, here, 5, 6. All right, I'm going to really quick count how many squares I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Not at quite 18, so I'm going to keep going. So another one, so I have 13, 14, 15, 16, 17, 18. I'm going to try again. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Perfect. I'm at my numbers. So I'm going to stop. I have 2 rows of squares, and each row has 9 going down. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I add these two, I get 18. So I know that 2 times 9, so 2 rows of 9 squares going down, will get me 18. So I'm going to come back and like, all right, so I know that 2 and 9 are going to be factors to get me 18. I'm going to try again. So this time I'm going to go up to number 3. So I'm going to draw 3 rows. So I have 3. And I'm going to make sure each row gets the same amount of squares, and I'm going to count all the way up to 18 and stop. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, so I'm going to double check this. Oops. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Perfect. So I have 3 rows, and each row has 1, 2, 3, 4, 5, 6. 6 squares going down. So I know 3 times 6 is going to get me 18. Oops. 3 and 6 are factors of 18. So I'm going to try and go on and go up to number 4. So I'm going to have 4 rows. Each row is going to get that same square. So I'm going to kind of just draw a head. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oop! Not each row gets the same equal amount of squares going down. Therefore, I know that 4 can't be a factor of 18. And so you can keep doing this on with number 5. Same thing, 1, 2, 3, 4, 5. And each row has to get the same amount of squares. Let me just pre-make it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh no! This square or rectangle doesn't get the equal amount of squares in each row. 5 is not a factor of 18. And if I jump to 6, oh look, I already have 6 right here, and I know that 6 times 3 are already factors for my 18. And so I can continue doing this with 7 and 8, but I'll quickly realize that these are the only factors for 18. 1 and 18 are a factor of 18. 2 times 9, these 2 numbers get us 18, so these are a factor. 3 times 6 gets me 18, so I know 3 and 6 are also factors of 18. We're going to try another number. We're going to try the number 5. So again, I'm going to always multiply the number itself by 1. So I have 1 row. I have 1, 2, 3, 4, 5. I know that 1 times 5 gets me 5. I'm going to continue. Let's see if I get 2 rows. I'm going to make sure that each row gets that same number, 1, 2, 3, 4, 5. And quickly I'll see that this rectangle is not complete. It's missing a box, so 2 is not a factor of 5. And I'll quickly realize that 5 only has 1 factor pair, itself multiplied by 1. 2, 3, or 4 multiplied by any number isn't going to get me 5. So I know automatically 5 only gets 1 rectangle. It can't have multiple ones like how 18 did. So that brings into our next session, which is prime numbers. Prime numbers can only create 1 rectangle, which means prime numbers have only factors of 1 and itself. And we saw that. We couldn't create any more rectangles with the number 5. It only could create 1. 5 is a prime example of a prime number. 5 multiplied by 1 are the only factor pairs for this number. You can't multiply 2 or 3 or 4 to get number 5. Composite numbers, though, can have multiple rectangles created, meaning it has multiple factors. The factors are the whole numbers that can be multiplied by another number to achieve the desired number you're finding factors for. So what that means is, we looked at our number 18, and we see that we can create multiple rectangles right here. 4 and 5 didn't work. So we have 3 times 6, 2 times 9, 1, and 18. 18 is a composite number. We created multiple rectangles, which means that it has multiple numbers that can be multiplied to get 18. So 2 times 9 are factors to get 18. 3 times 6 are factors to get 18. 18 times 1 also works, but we know that 2, 3, 6, and 9 also work to get 18. And so there we have it for our first week of our video for prime and composite numbers and finding factors using kind of our rectangles.